We have a problem here, and it's in cylindrical coordinates. Just start reading it, and eventually you find that it wants you to derive the equation passing through some point, and you're given the electric field. Don't get confused by this first equation here, because this is just it basically just says cylindrical coordinates. That's all it's saying. That's all really this equation means. Now we want a streamline equation, or an electric field line equation passing through a point. We've done these problems before, and the way you go about it is, in Cartesian, you would set some derivative equal to the components of the electric field. But in this case, it's a little bit different. We have the equation given for a constant z-plane, and I don't know why they have this rho here, but everything's the same except for there's a rho value there, and I'm just going to take that to be true. So it looks like this, and we're going to use that to find our equation. A little bit different than the one because we have this rho value, and I'm not sure why. If one of you guys could explain that to me, I'd be grateful. But you know, it's given in our problem here, so I'm not going to worry about it too much in this problem. Maybe I'll have to research that and figure that out. So we have our electric field values here. 2 rho squared sine 3 phi 8 phi. So now we just plug in our points simply enough. So the E rho component is 2 rho squared cos 3 phi this is 2 rho squared sine 3 phi, which kind of works out nicely, and then we have this stuff over here. So we see that these will cancel, and we are left with a cotangent that I will write as sine cos over sine, because I don't. We're about to do the derivative, so I'll move over this d phi because we're going to solve this by separation, and then we're left with d rho over rho. Now we can integrate both sides. This one will involve a little bit of u substitution. I think what I'm going to do with this problem is I'm just going to write the integration out, but I will show you, if you're interested, you would use u substitution for 3 theta, or 3 phi rather. That's going to give you the du d phi is 3, and d phi is going to be or du is going to be 3 d phi, and then you're going to do another substitution where, say, v is going to be sine of u, and then you end up with 1 over v. And basically what you end up with is you have to account for this 3, and you'll end up with the ln because you have this 1 over v. You can plug this into an integral calculator, or you can, some of my other videos have done this already. It's not a terrible integral. Just do some substitution, you'll be fine. So this ends up being 1/3 ln absolute value sine of 3 phi plus your constant integration. This is simply ln of rho. Right. Now we're gonna take these all to the e, so this will be e to the 1/3 ln sine 3 phi plus c equals e to the ln of p. Well, this side's easy. That's just going to leave us with the p, or rho. I keep saying p, sorry. this, we can write like this. Now this c, I'm going to, instead of writing plus c, I'll write times e to the c. Now this e to the c is going to be equal to c because of constant of integration. And this becomes rho. So now I will put this c out front. So now we have c e 1 to the 3 1/3. Now I'm going to put this to the exponent using my log rules. And now this whole e to the ln will cancel. So now you're left with c sine of 3 phi to the 1/3 power equals rho. And now we just need to plug in our point. And our point is 4. Rho is equal to 4. And phi is equal to 10 degrees. So you plug these in. We're solving for c, so what I'll do is I'll put rho over. I'll just move this over for now. Sine of 3 phi. Actually, I'll just plug them in now. So this will be 3 times 10 degrees to the 1/3. And this will be 4. Right? So now c is equal to 4 over sine 30 degrees to the 1/3 power. And what I get there, I actually don't have this written, so I'm gonna. The book was getting something like 7.14, but when I do this math, I'm getting like something closer to 5. Like basically 5 point. I'll call it 5.04. If you guys notice I'm doing something wrong, please let me know. But I think this is right. And now you would just plug that in. Rho equal to 5.04 times sine and there's your answer. Hope that makes sense. Bye.